of inventory also, which were uh, seasonal inventory and the safety inventory. We will talk about seasonal inventory and safety inventory later. Right now, we are more focused on role of cycle inventory in supply chain. So there are a few terms which we would like to discuss. I mean, we should know before we go ahead. That is, lot size is one term, or batch size. We also say that batch size. So lot size or batch size, you can say, is a quantity that a stage in supply chain either produces or orders. So some people are going. I mean, if you are manufacturing, You're going to produce it. You're going to make it. So in what quantity you're going to make it when you start making it at a given time. It's not like you're going to make it 24 cross 7, 30 days a week and 365 days in a year. You make it for some days and then stop the production. So, of course, that is also there. Continuous production is also there. But right now, we are more focused on the uh, batch, I mean, the lot size, where we are assuming that the production is not happening all the time. Then we have cycle inventory. So cycle inventory, you can say, is average inventory that builds up in supply chain because of the purchasing or because of the production. So average inventory that builds up in supply chain because because people purchase in lot sizes to exploit economies of scale, or they produce in batch some batch size with some batch size, so they can exploit the economies of scale again. So we denote cycle inventory by Q, which is, you can say, is the lot size or the batch size. We say Q is the lot or batch size. And then we say D is the demand per unit time. Okay. So there's another term. So we can say that cycle inventory as Q by 2. Q by 2. That is lot size divided by 2 is your cycle inventory because it's average. And it directly depends on the lot size which you are ordering or making. And average flow time. Average flow time. So average flow time is, you can say, the time elapsed between the point at which material enters the supply chain to the point which exit to the point when it exits. Okay, so that's the average flow time. So average flow time, we can say it as average inventory. So average inventory is Q by 2, and average flow rate. So average flow rate. Okay. Then average flow time for cycle inventory in a way. Now flow rate basically is nothing but the demand per unit time. So average flow time could be Q by 2 divided by demand rate. Okay, Q by 2. So this is the formula for average flow time. I hope it's clear. It's pretty simple, no doubts. Now let's take a problem. So let's say for a given supply chain, in a given supply chain, the manufacturer is having a lot size of 1000 units, and D is the 100 units per day is the demand. Demand for the given product is 100 units per day. So of course the cycle inventory will be Q by 2, will be Q by 2, which will be 500. You can also say this is the average inventory. So average flow time would be easy to calculate, 500 by 100. So that's your 5 days. So 5 days is the time which the particular product is spending in the supply chain. Let's say you make it today, so it will be exiting from your supply chain after 5 days. So what it is doing is this your cycle inventory is in a way adding 5 days to the time a unit spent in the supply chain. So because you are making in lot sizes, these 5 days are there. So you can say the because of cycle inventory you are having a flow time of 5 days. Ideally it should be high or low. Can anyone tell? Ideally this flow time should be high or low. You should have high flow time or low less flow time. So think about it. Since we are talking about inventory, we say that it should be low flow time. So larger the cycle inventory, the larger the queue size, more time is going to spend it in the supply chain. While why we say it should be lower, why, or you can say why lower cycle inventory. Why lower cycle inventory is better? Because one you can say is average flow time will be lower. Average flow time will be lower. The second would be mm, if it is spending less time in supply chain, that means you can realize profit earlier, and if you can realize profit earlier, you can invest it earlier, and earlier you invest, more you will gain in longer term. So working capital requirements low. And other than that, your holding cost will be low. uh, Holding cost, low inventory holding cost. Okay, so these are the basic reasons why you want to lower the cycle inventory. Now we go ahead. Let's say C denotes the material cost. If you are making something, C is the material cost. S is your fixed ordering cost. That also includes transportation. And H is your holding cost, which is given by H into C, where H is holding cost of one unit of inventory for one unit of time. It's like if I'm keeping a mobile phone in my shop, then what is the cost of keeping the mobile phone for 1 month in my shop? So that is your holding cost for one unit for one unit of time. Okay, and it is expressed in some percentage of the material cost. So that's why uh, expressed in percent in terms of percentage. So if the material cost is, let's say, 20,000 rupees and the holding cost is 2%, so accordingly your total holding cost will be calculated. Okay, now what do we want to do? The whole uh, idea behind all this talk is that we want to minimize total inventory cost. We want to minimize total inventory cost. Okay, now in order to minimize total inventory cost, what I need to do is I need to split the inventory cost into its components. So uh, total inventory cost can be splitted into three components. One is uh, cost of, you can say, manufacturing cost, or cost of products, plus, or cost of making, you can say, plus the holding cost, plus carrying cost. Okay, so your manufacturing cost, you can say, is C into D, or you can say material cost. It has all the things included in it. Material cost, that is simply making it. Okay, like you have machines, you have raw material, so all that cost is C into D, where D is the annual demand. I forgot to write that right here. D is annual demand. D is the annual demand. And then what will be the holding cost? So holding cost is average inventory which you are carrying for certain period. So let's say if it is yearly, we are talking about total annual demand we are writing. So holding cost also we are expressing in terms of years. So that will be average inventory multiplied with H into C, plus carrying cost is no, sorry, this is your carrying cost. This is your ordering cost. So in a way, if the total demand in a given year is D, and your lot size is Q, so every time when you're placing an order, you're ordering Q amount of quantity, or every time you're doing production, you are doing a production of Q quantity. So if D is the total demand, annual demand, and Q is If D is the total demand and Q is the quantity you are ordering every time, so how many times you are going to place an order? That will basically be D by Q. And we multiply this with the ordering cost. So let's say ordering cost, we are expressing it as capital S. This is your ordering cost. So you can see here we have an expression at our hand where we are saying that your total inventory cost, annual cost is given by CD plus QHC by 2 plus DS by Q. Now, if I have to minimize it, what can I do? I can do differentiation of it, DTC by DQ. Okay, so this is a constant term, so we'll go. There will be HC by 2 minus D by S Q square, right? Which will imply that, and considering that we are doing minimization, we can double differentiate it and we can find out that you will get a minima. So what the value of Q will be equal, this will be equal to 0, and then value of Q will be, we say it is Q star, that is at the minimum, 2 ds by H into C. Okay, so the optimal lot size. Optimal lot size. Optimal lot size means this is at the value of Q star, you are going to get the minimum value. Let's try to understand this graphically now. This whole expression we will try to understand graphically. So on y-axis you have Q, sorry. So on y-axis you have cost, and on x-axis you have Q. Okay. Now let's see the components of the total cost. So first component of total cost is C into D, which is your manufacturing cost or the ordering cost. This is constant and it does not depend on the lot size. So we can say it is a straight line. Then we have carrying cost. So we can say carrying cost is directly proportional or the holding cost is directly proportional. So here you go. And your ordering cost is inversely related with that. So with the quantity. So you can say it goes somewhat like this. Now when we are adding these three together, the superimposed curve would be somewhat like this. This is your total cost. And you can see at certain point of time where you get this minimum value over here. So this is your Q star. This is your Q star. Okay. And that's what we have found out that the total cost is minimum at Q star. This is your total cost curve. And this is your, you can say, holding cost, and this one is your manufacturing cost, and this one is your ordering cost. Okay, so resulting from this formula we can also find out optimal ordering frequency, that how often should I place an order. So optimal ordering frequency would be what? Number of times I'm placing an order, so that will be D by Q star. D by Q star, which will be 2S DH. This will be your N star, that is optimal ordering frequency. Any doubts till now? Okay, so we go ahead and we do a problem. Let's say demand of the computers is given as 12,000 computers per year, and demand rate is given as 1,000 computers per month. Holding cost is given as 20% of unit cost, and fixed cost, that is ordering cost, is given as $4,000 per order. So every time you place an order, $4,000 will be incurred. Now, can you quickly find out the value of Q star? That is, how much should be the lot size whenever you're placing an order? How much should be the lot size? Can you find out? I will show you the formulas also. Calculate the value of Q star. I'm giving you 2-3 minutes to do that.
Excuse me, sir.
Yeah.
Sir, would you need unit cost as well?
Unit cost. Yeah, I forgot to do. Unit cost is given as $500. Yeah. So it's coming out somewhat like this: 2 ds by HE. So you can see it is 2, and the demand is given as 12,000, and S is 4,000. Here H is 20.2 into C, that is 500. So you get this value Q as 980. Okay, good. So now we go ahead, and now if I have to find out average cycle inventory, average cycle inventory, or even if I write cycle inventory, it will be Q star by 2. That is, every time you're going to place an order, you'll be ordering 980 units, and this is going to be 490 units. What will be average flow time? Average flow time would be D by Q star. So that is going to be the demand is 12,000. That is not the average flow time, but this is the frequency. Sorry. So average flow time, as we have seen earlier, it's going to be Q by 2 divided by D. That is your demand rate. So 980 divided by 2, and D is your 1000. So you get it as 0.49 per month, right? Then if I ask you what is the reorder interval, reorder interval or ordering frequency, you can say, that is what is the time difference between two orders. What can anyone find out? What is the time difference between the two orders? Yes. So it will be, we know it will be 1 by that. So 1 divided by average flow time, 1 divided by average flow time would be 1 by 0.49. So what is this value? 1 divided by 0.49. Yes, tell me. What is the reorder interval?
Sir, it is around 2.04.
So 2.04. Now, it can be expressed in terms of time also and frequency also. So let's try to understand this through a figure. So I'm just taking off this formula for now, and I'll explain it with the help of figure first. So let's say we start with the Q star, that is 960 units here, 980 units, 980 units here. Okay, and it gets depleted right like this. And when it reaches zero, then we place an order, we get it back. Okay, so reorder interval means what is the time difference between these two? Reorder interval. Okay, now so n star is d by q. N star is d by q. So that is frequency with which, or how many in a year, how many such triangles will be there. So d by q is what 12,000 divided by q, that is 980. So what is this value which we get? N star. Yes.
12.24.
12 point.
24.
12.24. Okay, that means there will be 12.24 such cycles. Now there can't be integer, it has to be integer only. Okay, so you can't have lesser inventory, you can only have larger number of cycles, so there will be 13 such cycles in a way. Okay, and these 13 cycles have to happen in a year. So 12 months divided by 13 will give me what? 12 months. So in 12 months you are ordering 13 times. So can you convert it into days? 12 by 13 is how much? Point 0.92. So you can say 0.92 month. 0.92 months. Or how many days? 27.69 days. And you can again round it off to 28 days. Now there's one thing. We have rounded it off twice. We have rounded it off here. We have rounded it off here. So what should be the right practice? Shall we do it twice rounding or shall we do it at the end?
Sir, at the end.
Right. So let's correct it again. So n star was 12.24. We take it as it is. That is 12.24 is the frequency with which we are ordering. 12.24 months. Okay. Then we go ahead and find out in terms of months. So 12.24 divided by 13 will give me 0.941. And once I get 0.941, the next thing I'm going to do is I'm going to convert it into days. 0.941 into 30. So that gives me into 30. So that gives me 28.24 days. So now I can make this one over here. So every time I'm placing an order, sorry, I'm placing an order for 980 units and I place an order after every 29 days. Okay, so this is your reorder interval, 29 days. Is it fine? So that's how we do this.
Excuse me, sir.
Yeah.
Sir, shouldn't it be 12 by 12.24?
No, why?
So
See,
we rounded it off to 13 in the previous case.
just a second. Maybe I have made a mistake. Let me see. Oh, yeah. So sorry. Yeah. So it has to be, let's correct it. Let's correct it. So number of orders in a year. 20.24, you know? And so the time difference between the two orders would be just like earlier what we are doing. So 12 divided by 12.24 is going to give me the time between two orders. Time between two orders. So that's going to be
So 0.98,
0.98.
29.4 days.
Then you multiply it with 30. So 29.41. So then we can round it off to 30. So after every 30 days, we are placing an order. Okay. So I hope it must be clear. So let me just give a brief, quick review of whatever we have done. So initially we derived total inventory cost. After deriving, we see that inventory cost is having three components: manufacturing cost, holding cost, and the ordering cost. After finding out that, we found out the total cost, and then we differentiated it with respect to the lot size. We found out optimal lot size, the formula for the optimal lot size, and n star value, that is the optimal ordering frequency. We take a problem, and in this we were supposed to find out the optimal lot size and the optimal ordering frequency and uh, optimal reorder interval. So that's how we did all the calculations and we found it. Okay. Now going ahead, now I ask you to calculate the total inventory cost. Total inventory cost. Calculate the total inventory cost now, all of you, and send your calculations in the WhatsApp group. Yes, anyone found out the value of total inventory cost?
Yes, sir. Just last step. I'm
Okay.
good.
Okay. So all you have to do is C into D plus H Q by 2 into C plus D by Q, right? Q star you can say. So, 5000. What was the value of C? 500. 500 into the demand. Demand per year is 12,000 plus holding cost is 20% of the unit cost, and lot size Q star was 980 by 2 plus total demand is 12,000 units divided by Q star is 980 into, I forgot to write the cost, S into the ordering cost is 4,000. So that's how we calculate the total inventory cost. Now we will continue our discussion. Yeah, 60,097, 980. So this is the annual cost of inventory, which is very high. You can see that. Now in the next class, we will be working on ways how can we reduce this further. Okay. So let's continue our discussion. Now next week we'll definitely have a quiz, and we will probably have it on Monday only, because next week Wednesday I will not be taking class. I'll be traveling. So Monday and Tuesday we'll be having class in the next week. So Monday I will be taking the quiz. Okay.
Sir, after the presentations, then
Yeah. So just a second. Let me stop the recording.